Hello, Precalculus student. This video is for Chapter 1.5. No, Chapter 1.7, Inverse Function Part 2. We are continuing with working on finding inverse. If I'm giving a function, so suppose I have a function from a formula, and I want to find a formula that can give me the inverse, where so that this inverse will act such a way that when I apply it to my output, y, this inverse will give it back, give my x back. Okay, so the easiest one would be like my function x. My function is x plus 1. I just increase it by 1, right? So this is my y. So how do I get back x? I would take the y in y function and I would minus 1, right? X minus 1. So of course I call it x because this is my input. So the plus 1 is the original function, the minus 1, this is the new function. So you can think of just whatever that f has done, you just do the reverse of it. That would be the inverse. But if there's multiple operations, so how do we take care of it? So the way to do it is use a swap and no solve for x and then switch xy. So in this box, they replace they solve for x, and then because x was the output for y, so they switch x and y and then write it as the inverse function. In other books, they actually switch x and y first, and then they solve for y. So both are fine. Okay, I'll do one. I'm more familiar with this way, so I'm gonna do this. But this OpenStax book actually use this method. They solve first before they switch. Okay, so first of all, my original function is f of x equal to 4x plus 3. So if I input 0 to it, I get 3. If I input 1, I get 7. So what is the formula so that can give me back my original x? So the way I'll do is I'm going to use the switch and solve first. So I write the f of x as y. I don't want to write f of x anymore as the output. Now I switch x and y, because it was the output for the inverse function, and then I want to solve for y. So to solve for y, I take off 3, and then to have y by itself, I divide by 4. So I end up having y is equal to x minus 3 over 4. Right? This y is the inverse function, so I write it back as the inverse function notation equal to x minus 3 over 4. So that is the inverse function. The original function is 4x plus 3. The inverse function is x minus 3 over 4. Every time I start with something, for example, if I have x equal to 0, y is 3, right? So if I have 3, I do 3 minus 3 is 0. So I get back to 0. What about if I have a function that involves, exponent? So I'll do the solving first. First is rewrite x minus 2 cubed minus 1. And then I switch the x and y. Y minus 2 cubed minus 1. And I solve for y. So how can I get the y out? Well, first of all, I get rid of the minus 1. So by adding 1 on both sides. So I have my y minus 2 cubed. How do I get rid of the cube so that I can free the y out? I do cube root, right? So this is cube root of x plus 1. If I do cube root on this side, this and this would cancel, so I would equal to y minus 2. And finally, I add 2 on both sides, so the function is x plus 1, and then outside minus 2. So I write it back as a inverse notation. Inverse function is equal to cube root of x plus 1 minus 2. Next example is if the original function is a rational function, meaning it has some things in the numerator, some x in the denominator. So I use this four-step method. First of all, change f of x to y. And I switch x and y. You can solve for x first and then switch later. But this I'm used to doing that. 5y now minus 1. Now I'm going to solve for y. Then this is difficult because I have 2y here. So how do I solve for y? So I just say 5y minus 1 multiply and that's y equal? No. When I say solve for y has to be all gone, has to be on one side only. So but nevertheless, I'm going to multiply 5y minus 1 on both sides. So I would have 5y minus 1 times x is equal to y. So now this is not the answer because I have to make all the y on this side. So first is distribute. So I have 5xy minus x is equal to y. I want to move everything on this side. So negative x left over, y minus 5xy. So now I have all the y terms on one side. Because they're all y terms, I can factor 1 minus 5x. So I factor the y out, so I only have one y now. So y would be negative x over 1 minus 5x. If you want to switch the negative, you can say x 5x minus 1 also. And write it back in inverse function. It would equal to negative x over 1 minus 5x. Or if you multiply negative 1 top and bottom is x 5x minus 1. Turns out that it's the same as the beginning. Example 4 is something that has a fraction as a coefficient. So let's see. So I use the same methods. First of all, we replace f of x by y. And then I want to switch, right? Switch x and y because x was actually the output. So then I do plus 2 equal to 1/3 y. And how do I get rid of the 1/3? I multiply by 3. It's plus 2 equal to y. So the inverse function is f inverse is equal to 3x plus 2. Okay, so that's the inverse function. The next things we want to talk about is restricting domain. Sometimes if the function is not one-to-one and you really want to do an inverse, what can you do? Can you just say that no inverse? We can actually restrict the original function to a restricted domain so that it become a one-to-one. A good example would be f of x equal to x squared plus 1. So I draw the picture here. X squared plus 1 is like this, right? So you can see that when you do horizontal line tests, it's not one-to-one, right? But if I just restrict the graph here on this side, the positive side, so that means I restrict domain to 0 to infinity for x, then this become a, when x is greater than equal to 0, right? So that's the domain. Then this become a one-to-one, and I can solve for the inverse. The inverse would be y equal to x squared plus 1. Use the four-step method. X is equal to y squared plus 1. And then I do x minus 1 equal to y squared. And then I say y is square root of x minus 1. Why do I just do the positive instead of positive and negative? You can see the original x is positive, right? The original x is positive. This is the domain. The domain is the range. So I use positive. And you can see that this is a valid function. So f inverse of x is positive square root of x minus 1. And this new function's the domain would be x is greater than equal to 1. What about a restricted domain for f of x equal to x minus 3 squared? So if I'm to graph it, x minus 3 is right 3, right? Right 3 for x squared. So if I'm to graph it, it will be like this. Again, it's not a one-to-one function, so I'm going to restrict the domain on this side. So we would say restrict the domain for 0. No, the domain is 3, not 0, 3 comma infinity. So x has to be greater than 3, right? So then I'm going to solve for an inverse. So y equal to x minus 3 square. Switch x and y minus 3 square. Square root of x is positive. Y minus 3. Why? Because it's here. And then we would say square root of x plus 3 equal to y. And this is the new inverse. This is the inverse of x minus 3 squared. Square root of x plus 3. You can see that the domain is always 3 and then add a positive radical. So this is the last things we want to talk about is if someone don't give you the formula and you are to actually graph, but give you a graph, you're actually to sketch the graph of the inverse. So how do I do? So the idea would be find some point of xy on the original function, rewrite them as xy, yx, and then we flag it. Then those would be the graph of f inverse. Another way is to reflag. So I'm going to just do the table one. Okay, xy. This is the f function. That function I see 1, 1. Try not to do 1, 1, 2, 2, and I see 4, 2, right? 4, 2. So f inverse would have what a function? Would have xy equal to also 1, 1, but 2, 4, right? So I'll do 1, 1, and I'll do 2, 4. So, and I have 0, 0. So I know it is symmetrical. So I don't bend this way, but bend the other way. And like that, right? So that is the inverse function. What about this? This is a line. It is 1 to 1, right? So let's do some point for the original f functions. I guess 0, 3. 2, 2 is not very good. 4, 1, right? We can say 2, 2. It's not very good because it's on both. X, the inverse would be 3, 0, right? 1, 4, and 2, 2. So let's graph it. 3, 0, 3, 0. 1 all the way to 4. And 2, 2. So you can see it is like that. This is the inverse function. So although you don't know the formula, you can draw it if you can find some point, and you can see that it is symmetrical over the x equal to y line. So that is all of 1.7.